Hi students, welcome back to my channel Evolve Solving Physics. Today we are going to discuss the relationship between current and drift velocity, current density and drift velocity. These two relations are going to discuss in today's class. So we all know that the current formula is I is equal to Q by T and the units for current is ampere. And drift velocity units is meter per second. Drift velocity has the units of velocity same as drift velocity units. So now we are going to find the relationship between current I and drift velocity Vd. So let us consider a conductor. This is an conductor. Why I am taking conductor? Through conductor only the electric current will pass. This is an conductor. Conductor is of length L. L is the length of the conductor and A is the area of cross section of this conductor. And now we are giving an electric current to this conductor. Then number of free electrons will be passes through that. Let us consider a conductor of length L of area of cross section A. Now a current is applied to this conductor, in which the number of electrons will flow through this conductor. So E is the charge of each electron and N, how many electrons are flowing through the conductor here? We don't know how many electrons are flowing to the conductor, so we consider it as N. N is the number of free electrons are electrons. Free electrons moving in a conductor per unit volume. So as you all know that the number of electrons passing through the conductor when an electric field is given throughout the volume of the conductor. So total number of electrons is written as NaL. Why I am writing NaL? Because in a conductor the length is L and area of cross section is A and the number of electrons flowing through the conductor is N. So NaL. These are the total number of electrons moving in a conductor. Now total charge on conductor is equal to NeAl. Total number of electrons in the conductor is NaL, but total charge on conductor, that is Q. So Q is equal to NeAl. Why I am writing NeAl means has number of electrons passing through the conductor of area of cross section A, length L, but each electron charge is E. So Ne represent total charge passing through the area of cross section A and length L. I said in previous class that Q is equal to Ne. So N number of electrons and E is the charge of each electron. That forms the total charge of an electron. Q is the total charge of an electron, that will be equal to number of electrons moving in a conductor and each electron having a charge E. So I am writing as NeAl. Now, so we want the relationship between current I and drift velocity. So I equals to Q by T. We got Q here, that is NeAl. Now we are going to calculate T. By substituting Q and T values, we will get the relationship between current and drift velocity. Now to find T here, we know that velocity is equal to displacement by time. So we want time here, send it to left hand side. Vt is equal to displacement, T is equal to displacement by velocity. So velocity is taken as drift velocity here. Why I am taking drift velocity? I said that the average velocity of an free electrons passing through the conductor. So V equals to Vd. So in place of velocity we are taking the drift velocity, and displacement is taken as L. Why I am taking L? So here length of the conductor is taken as displacement. So L, substitute here, T equals to L by Vd. So this is considered as equation 1. This is considered as equation 2. So substitute equation 1 and 2 in I equals to Q by T. So Q is, what is Q here? NEAL. NEAL by T value is L by Vd. L by Vd. Make the reciprocal here. So make the reciprocal of denominator. We will get NEAL into Vd by L. LL will be cancelled. So NEA Vd. So this is the relationship between current I and drift velocity. I equals to NEA Vd. So this is the very important formula for the students who are preparing for EAMCET, JEE and NEET. So I equals to NEAD. This is the relation between I and Vd. So in problems what they will ask means they will give current I, number of electrons and area A. Then they say to find drift velocity. So by using the formula I equals to NEA Vd, you can calculate the value of Vd. E is the charge of each electron. The value of charge of each electron is 1.6 into 10 power minus 19 coulomb. So they won't mention E value. So you have to take the value of E, that is 1.6 into 10 power minus 19 coulomb. That is charge of each electron. So I equals to NEA Vd. You have to substitute I, N, A, E. You will get the value of Vd. Now we are going to find the relationship between current density and drift velocity. Relation between current density J and drift velocity Vd. So we know that the current density is the ratio of current to the area, and the units of current density is, current is ampere and area is meter square. So the units for current density is ampere per meter square. So this is considered as equation 3. Substitute equation 3 in above equation. So J equals to I is NEA Vd by A. AA will be cancelled here. J equals to NEVD. So this is the relation between current density and drift velocity. J equals to NEVD. Here I equals to NEAVD. So these are the two important relations that you should remember. So you should not only remember the formula, you should also remember the units for that terms. So these are the relation between current and drift velocity, current density and drift velocity. In next class we are going to discuss some problems based on current, instantaneous current, and relationship between current density and drift velocity, current and drift velocity. So if you have any doubts, please comment me in comment box. Please like, share and subscribe my channel. Thank you.